Hey, welcome to the last video, or last worksheet I should say. I think I'm going to try to make one more for the final exam review, but I don't plan to make the final exam very difficult, trust me. But we will talk about what will be on it, and, we'll get through it. No big deal. Just one last test, right? Okay, so this one, we're talking about just one section in week 6, and it's 4.4. We work on equations that have exponential expressions like this one, or logarithmic expressions. Now with exponential expressions, you have two ways. You can either try to make the two bases the same, which is what we'll do for 1, 2, and 3, or we can do the natural log of both sides, which is what we'll do for 4, 5, and 6. So this one, I see that the base is 3, and I really wish I can make his base 3, and I can, if I can remember that 3 to the third is 27. So if I rewrite 27 as 3 to the third, and then over here I don't do anything, he has the same base as him. Now the only way that this can be true, that this guy equal to this guy, is if this exponent is equal to this exponent. So you can rewrite the equation without the bases, like so. Oh, look, that's a nice little linear equation, ain't it? X is equal to 1. Lovely. So with exponential equations, the first way is try to make the bases the same. Now for something like 27, we can go, that's 3 to the third, probably a little easier than most. For number 2, we also have a nice one. So this one, you have 2 raised to the 3x minus 7, and that's equal to 4. Well, 4 can be rewritten as 2 squared, right? And so the same thing happens. We're going to go, we don't need those bases anymore now that they're the same, and that gives us 3x minus 7 equal to 2. And then we solve the nice linear equation that's left over, and we get x is equal to 3. Nice. And then we get to number 3, and number 3 starts with 4 raised to the 7 minus 3x, but it's equal to 1 over 16. Now, if this were 16, that would be 4 squared and the bases would match. That's great. But since it's a fraction, you have to remember that negative exponents make that happen. Yeah. So with a negative exponent, it becomes 1 over 4 squared, which is what 1 over 16 is. That's why if it's a fraction and you want to change its base, make sure it's negative exponent. See, these, they're positive. Okay, and that's all there is to it other than just setting those two equal to each other. 7 minus 3x equal to negative 2. And then we subtract 7, and we get negative 3x equal to negative 9. And then we divide and we get positive 3. Again, positive 3. Okay, so that's solving equations by changing the base. Number 4, we start with solving equations by natural logging both sides. So I'm going to leave a little space right here. This is 9 to the 5x equal to 3.6. Now we definitely need a calculator to do this. Or do we? Hold on, let me look at the answers. No, we don't need a calculator. It's helpful, but we don't need it. So whenever you can't make the base the same, like if this was 3, I could do it, but this is 3.6, and I can't make 3.6 raised to something equal to 9, so I have to just do the natural log of this thing equal to the natural log of this thing, okay? Now, anytime you have an exponent with a log, it can come down. That was something we learned when we were expanding. Remember expanding? You should. So this 5x goes in front, and this natural log of 9 is right there without an exponent. Natural log of 3.6. Okay, so you got 5 times x times natural log of 9, and we want to get x by itself. I'm going to divide those numbers from both sides. And that will cancel them, and you get x is equal to this thing, which I'm just gonna, you don't have to do anything with that. That's what the answer looks like, right? So the thing you can't do is you can't divide 3.6 by 9 or anything like that. You can't make two natural logs like this into something else. Remember when we were condensing? If we were subtracting on the outside, we would condense them with the divide. But this is dividing on the outside, and there is no condensing thing for that. So we just leave it like that, and it's done. So natural log may look a little bit funny, but it's actually usually less work than changing the base. Now here, if we do the natural log on both sides, something magical happens. Ooh, I like a little bit of magic. So natural log of e, remember this is base e, and anytime the bases match, they cancel, so you're just left with 4x. Cool, huh? See here, we didn't have that. It wasn't base e, it wasn't an e here, so we had to bring it down and then divide. Here we didn't have to bring it down, or we could have if we wanted to, but natural log of e is 1. So, and then we divide by 4, and that is the answer. Again, do not divide. This one's in a natural log and this one's not. So don't do that. Just leave it. Leave it alone. All right, next we have e to the x plus 6, and they didn't put parentheses around here, but I'm going to because that, you know, can cause problems if you don't see the as a single thing in the exponent. All right, so when we natural log both sides here, we get the same deal, natural log of e, so that's going to cancel, and then natural log of 3 over here. So x plus 6 equal natural log of 3. And then we subtract 6 from both sides. Now here's the thing. You have to be careful. So if you say minus 6 over here, you might write natural log of 3 minus 6 and then go, wait, that's natural log of negative 3. But no, that's wrong for a lot of reasons. Instead, what we're going to do is anytime we have a whole number dealing with a natural log, we're going to put it in front. Okay? That way I don't get confused. And this is the final answer for this, negative 6 plus natural log of 3. I don't know what that is. I would have to use a calculator to find a decimal for it. And you could do that if you wanted to. You could find a decimal for all 3 of these answers and give me the decimal answer if that's what you want to do. But since the answer choices are in natural logs like these, I'm going to leave them alone. Okay, so 1 through 6 was the exponential equations, and then 7 through 10 are the log equations. So if you start off with a log, you get log base 6 of x plus 3, and that's equal to 1. Then what you want to do, there are 2 types, by the way, for log equations as well. One where just one term does not have a log. So like this 1 doesn't have a log. So this is one of the type 1. This is what we call type 1. And type 1, you want to get a single log. You want to condense, get a single log by itself, and then we're going to change it back to exponential by starting with the base, going across the equal sign, and then coming back across the equal sign. Yeah, something we learned in 4.1. That's right, keeps coming back, right? So this 6 to the first is just 6, and this is x plus 3, so I just subtract 3, and I get 3. That's what my x is. Solving log equations, eh? Not so bad. Number 8, natural log of x equal to 3. This is also type 1 because this 3 does not have a log, natural log. So I'm going to get just one log on one side. That's what I've done. That's what I already have. And I'm going to start with the base, e. I'm going to go across the equal sign for its exponent, and then I'm going to come back across the equal sign for what it's equal to. Hey, x is equal to e to the third. That's good enough for me. Again, you can find the decimal if you want, but not important. Like if you were going to tell somebody a measurement, you would need the decimal. But for math class, you just leave it like e to the third, and us mathematicians will go, oh yeah, oh okay, I know what that is. Log 5 plus log of x minus 2. So this is a type 2 log equation. I don't know if I labeled them type 1 and type 2 in the notes, and if I didn't, I'm sorry. But with a type 2 log equation, every single term, 1, 2, 3, they all have log. It's all the same log. So the thing you do with that is you want to condense these two into one. And remember, plus on the outside means times on the inside. And you can use a parentheses instead of a bracket. I was just, filling myself with them brackets. Not even a pretty bracket. Huh. Oh, now it's even worse. Oh, God. Anyway, so once you've condensed into a single log equal to a single log, then you can just cancel the logs. Just like with change of base in the previous problem. I'm going to distribute here. Okay, so that gets rid of the logs. And this only works for type 2 where every single term is a log. You condense into one log on each side, and then you just cancel the logs. Now you can't do it before you condense because you'd end up with 3x equal to 5 plus x minus 2, and that's not what I have. This is not the right answer if you did that. But in this case, what I would do, I would subtract 5x. Lots of ways to solve this. And then divide by -2, and you get positive 5. Okay. Oop, can't see that. Okay, now, here's the thing about log equations. Okay, so log, you cannot take the log of a number that's less than 1. No, you cannot take the log of a number that is equal to 0 or less. So anything between 0 and 1, you can take the log of it. And if you look on your calculator and you go log of -5, it'll tell you error. But if you say log of 0.1, it'll give you a negative answer. So between 0 and 1 is fine, 1 is fine, log of 1 is 0, and then log of negative numbers are not fine. Neither is log of 0. So here's the thing. When I'm doing log equations, I'm plugging in numbers for x to see if this side is equal to this side, right? So if I plug a 3 in, I get log base 6 of 6. Yes, that's good. If I plug in e to the third here, I get natural log of e to the third, and yeah, that's good. Because that's a positive number raised to a positive number, right? If I plug in 5, I get 15. That doesn't change. This is 3, so it's all good. All positive numbers are good. Number 10, though, I think I put that problem in there so that you can see that sometimes the answer doesn't work out. So with number 10, we have log of x plus 4 in parentheses. And that's equal to the log of, what is that, 4x minus 5. Oh, hey, look, they're condensed already. There's just one log equal to one log. This is type 2, so I can just go ahead and cancel those logs out, and I get x plus 4 equal to 4x minus 5. Nice. So we're going to subtract x, or at least I will. You may do it differently, but that's okay. As long as you get to the right answer. And then you're going to add 5. You get 9 is equal to 3x. That's canceled. And then you divide by 3 and you get x equal to 3. Now, if this is going to work, 3 has to not create any problems. So 3 plus 4 is 7. That's good. And then 4 times 3 is 12. 12 minus 5 is also 7. That's good. So he's a good answer. But I didn't put any problems in the worksheet, nor will I put one on the quiz where you have to check and you might get a negative answer, a 0, and that wouldn't be an answer. So I think for the quiz, you don't have to worry about that. You just do the problem, whether it's type 1 or type 2, and then you'll be fine. You don't have to check as much. Okay? So, yeah, that was the last worksheet. Aren't you excited? Yay!